All right. I need your attention up here, please. For today, we are still simplifying rational expressions. We are still looking at multiplying and dividing expressions, but the ones we're multiplying and dividing look different than they did on Friday. You don't just have a monomial or one term on the top and bottom of each fraction. You have actual polynomials on the top and bottom of each fraction. So we'll look at those, and then also we'll look at simplifying complex fractions. So a complex fraction is when you have a fraction within another fraction. So we'll look at how to simplify those. Starting off with example 1a. So we have two expressions being multiplied. So again, make sure you're paying close attention to the operation symbol in between. With multiplication, we know we just multiply across the top and the bottom. However, before you start multiplying, I would not recommend multiplying right away because you'd have to distribute or FOIL, and then you're going to end up with these really big polynomials, and then trying to factor those would be tough. So before you actually multiply across, I would factor the top and bottom of both fractions if you can. So for example, if you look at the first fraction, the top of the first fraction is 8x minus 20. Is there a way we can factor that? A way we can rewrite it by factoring? It's not a trinomial, like the bottom is a trinomial, which we could then make a diamond. The top is not, though. How could we factor the top? Cora? Yes, there's a GCF of 4. So we could take out a 4, and we'd have 4 times the quantity 2x minus 5. So I'm just going to cross out the 8x minus 20, so we have the factored form written there. And then on the bottom of that fraction, like I said, this is a trinomial, so we can set up a diamond. We'd be multiplying to negative 35 and adding to positive 2. Are there two numbers that work? Yep, negative 5 and positive 7. So this could be factored as x minus 5 times x plus 7. So cross out the bottom part there just so we have the factored form. And then if we look at the next fraction on the top, that's another trinomial. So if we set up a diamond for that one, we'd be multiplying to 10 and adding to negative 7. Two numbers that work?
Negative 5, negative 2.
Negative 5, negative 2. So that's x minus 5 times x minus 2. And then on the bottom of that fraction, we have 4x squared minus 16. Now, whenever you factor, you should always remember, look for that GCF first. So there's two things we can do to factor this. First of all, the two terms have a GCF of 4. So I'm going to factor out the 4 first. And if I divide both by 4, then I have x squared minus 4. But then I can factor x squared minus 4. What would this be in factored form?
X minus 2 and x plus 2.
Yes, it's a difference of squares. So it's x minus 2 times x plus 2. This would be the fully factored form down here. Okay, so then I'm going to rewrite this. Everything across the top is multiplied. I just have everything factored. Same thing with the bottom. Everything across the bottom is multiplied. It's just all factored. So keep it factored. I'm just going to write it all together as one fraction. So along the top, I have 4 times 2x minus 5 times x minus 5 times x minus 2. And on the bottom, the 4 that I had in that second fraction, I'm just going to write that in front. So I have 4, and then from my first fraction's denominator, I have x minus 5 times x plus 7. And then from the second fraction, I have x minus 2 and x plus 2. Okay, so make sure everything is factored. And now you look to see what are you able to cancel. Some common factors. So we have on the top and bottom, we can cancel out the 4s, and they both would just become 1s or just cancel out. We have an x minus 5 on the top and the bottom. And we have an x minus 2 on the top and the bottom. That's all they have in common. So fully simplified, the top would just be 2x minus 5. And the bottom would be x plus 7 times x plus 2. And you can leave your answer in factored form. Okay, any questions on example A? Okay, so then for example B, I know some of you are still writing, so I don't want to move this up too far just yet, but for example B, these two fractions are being divided. What do you have to do first if you have division? What did we do on Friday if you're dividing two fractions? Yes, so rewrite this first before you start doing what we did for part A. You have to rewrite it as multiplying by the reciprocal of the second fraction. So the first fraction would stay the same. But then I'd change the division, would now be multiplication, and I take the reciprocal of the second fraction, so it's now 6x plus 42 on top over x squared minus x minus 12 on the bottom. I'm going to move this up here. And now that we've written it as multiplication, we work through it just like we did part A. So we need to factor everything as much as we can. So on the top of that first fraction, I have a diamond, x squared minus 9x plus 20. So to factor it, we'd be multiplying to 20 and adding to negative 9. What numbers would work for that top one? Multiply to 20, add to negative 9.
5 and, oh wait, negative 5 and negative 4?
Yep, negative 5, negative 4. So that would become, I'm actually going to do this time, because I'm going to write it as one big fraction anyway. So this first one is going to factor to x minus 5 times x minus 4. So I'm just writing it in factored form, but in the product right away, in my final one big fraction. So I factored that one. On the bottom of that first fraction, x squared plus 10x plus 21, so multiplying to 21 and adding to 10. What numbers work for that one? 3 and 7. So the denominator of that first fraction, which I'm just going to write in the product right away, would be x plus 3 times x plus 7. So I factored that one. I'm done there. In the second fraction on the top, I have 6x plus 42. How do you factor that? It's not a trinomial. Well, it's not a difference of squares because we don't have an x squared. What should we always check for? GCF. GCF of 6. So I'm still going to write it over here. It is being multiplied. I would have 6 times the quantity. If I divide both by 6, then I'd have x plus 7. And then, so I factored that one. And then on the bottom of that second fraction, I have another diamond. Multiply to negative 12, add to negative 1. What numbers work there? Negative 4 and positive 3. So x minus 4, x plus 3. And then we have to see what cancels out. Looks like there's an x minus 4 on the top and on the bottom, and an x plus 7. And that is it. So then on the top, I'm just going to write this 6 in front of the x minus 5. So on top, I have 6 times x minus 5. Over on the bottom, I can leave this as x plus 3 times x plus 3, or because they're both the same, you could write it as x plus 3 quantity squared. It doesn't matter to me. Either way is fine. I'm just showing maybe the less obvious way to write it. You could write it that way. Okay, so I would like you, I'll leave this up here, but I would like you to simplify part C. And be careful with part C, you are dividing. So work through C and simplify that expression. And then I'll come around in a minute. I can answer questions. I can check what you have. But work through one of these without me leading you through it. That might confuse you because I might say yeah, that's not right. All right, I know some of you might still be working, but just double check what you have. It should simplify to 2 times d plus 1 on top, d minus 1 on the bottom. So I need your attention up here, please. Couple of things. I saw this on some papers, and this sometimes ends up confusing students, and then they think things aren't going to cancel. Make sure when you're factoring, do not start changing your variables to x. Then you might think things don't cancel if you start to change your variable. And then also just remember, when you have division, rewrite it as multiplying by the reciprocal. Don't forget that you can factor out a GCF. That is often the factoring method forgotten. Are there any questions on C before we move on? Okay, so then for the last set of examples, these are simplifying complex fractions. So as I said, a complex fraction, it's a rational expression when you have a fraction within another fraction. So in the numerator or denominator or both, you have another rational expression. So to simplify these, you have to remember that a fraction just represents a division problem. So you want to rewrite it first as a division problem and then work through it just like you would have worked through examples B and C for example 1. So if we look at example 2, we have a complex fraction. So this here is the fraction bar for the large fraction. We have a fraction on the top and the bottom of our overall fraction. So again, a fraction represents division. Rewrite this as a division problem. So this really means I have my top fraction, so x minus 2 quantity squared over 2 times the quantity x squared minus 5x plus 4 divided by the bottom fraction, x squared minus 4 over 4x minus 10. Okay, these are equivalent the way I have that written. So you can rewrite it as your top fraction divided by your bottom fraction. But now you just did an example like this. When you're dividing, you rewrite that as multiplying by the reciprocal. So this means I have my top fraction, x minus 2 squared, all over 2 times the quantity x squared minus 5x plus 4, multiplied by the reciprocal of my second fraction. So my second fraction is now 4x minus 10 on top over x squared minus 4. And now work through this like a multiplication problem. All right, and I'm going to factor this and again write it as the product right away. So for the first fraction, the numerator is actually already factored, x plus 2 quantity squared. I'm just going to separate it, is really x minus 2 times x minus 2. So that's already factored. I'm just going to write it separated versus the condensed form it was in. So I have the top of the first fraction rewritten. The bottom fraction then, that 2 is going to stay there, but the trinomial x squared minus 5x plus 4 I can probably factor. So I would be multiplying to 4 and adding to negative 5. Carter, what did you say it was? Okay, so on the bottom I'm going to have still the 2 in front, and then x minus 4, x minus 1. And then if I move on to my second fraction, on the top I have 4x minus 10. How would I write that in factored form? Yes, there's a GCF of 2. So 2 times the quantity 2x minus 5. And that's just being multiplied along the top. So that's factored. And then the bottom of that second fraction is x squared minus 4. How do I factor that? Yes, difference of squares, x minus 2, x plus 2. Okay, then you look to see what can you cancel. So from the top and the bottom, it looks like I can cancel an x minus 2. And I can cancel the 2 GCFs of 2 that were there. Those would cancel out. Otherwise, everything appears to be different. So the final simplified result would be x minus 2 times 2x minus 5 on the top over x minus 4 times x minus 1 times x plus 2 on the bottom. And that would be fully simplified. Okay, so I'd like you to simplify example 3. That's another complex fraction. Simplify that one. And when I come around to check, I'll also pass out the assignment. But I can also answer questions if you have questions.
Oh, sort of. I know I'm not. That's kind of oh, you guys are already managed. Yeah. Nope. I didn't either. I'm so confused. Oh, I mean, Abby just like. Yeah. All right. I don't know. I'm gonna ask. See who's gonna be on my team. I had to call my mom to keep my number. No, I'm waiting for them to respond. They should $5. Yeah, but it won't put my whole email to the visit to an account. I'm like, no, I didn't mean to do that. I emailed them personally. This is the response. Yeah, it makes sense other than like, I do your new email, but I mean, I don't even have the old stuff, the old email stuff. Yeah, I'm mad about it all night. And they're like, I don't remember my password. That's why I have.
All right. Just quickly, can I have your attention up here, please? So this is just reminding you, I know I talked with individual groups about this already. Guys, I need it quiet. So after you rewrite it as division and then rewrite it as multiplying by the reciprocal. So first of all, factoring differences of squares. X squared minus y squared factors to x plus y, x minus y. Y squared minus 49 is y plus 7 times y minus 7. The y plus 7 and y minus x here are already factored. You can't factor them. When you're canceling x minus y and y minus x, they're not exactly the same. So remember from Friday, if you have two quantities being subtracted, but they're just flipped around, you can cancel them if you factor out a -1 from just one of them. Because if I take a -1 out of here, then I end up with -y plus x, which then if I flip it is positive x minus y, so they would cancel. But that means your answer is then negative. So it'd be negative and then x plus y on top, y minus 7 on the bottom. So don't forget about taking out that negative in order to cancel those.